Alright, this is quiz 7, and actually both forms were exactly the same, so I'm just going to do the entire quiz in one go. Alright, so given the following demand function, Q equals, find the elasticity function. Alright, so in this case remember that the elasticity is negative dq dp times p over q. Okay, and if you can do that, well, you know, dq dp is going to be negative 4p plus 33. Okay, well, that gives us the elasticity then. It's going to be negative at 4p plus 33 times, let's see, got p over, I can substitute q in for p, calls, was it negative 2p, oops, should be another negative in there, negative 2p squared, crap, 2p squared plus 33p. Alright, keep in mind all these p's, you can get this, negative negative, at the end of the day it should be, let's see, 4p squared minus 33 over 2p squared plus 33. Oops, forgot the p up here, p there. Okay. Well, one thing you can do here is, if you're real careful, you can cancel out some p's. But you gotta do it real careful, and you end up with 4p minus 33 on top, and negative 2p plus 33 on bottom. And so either of these two would be accepted as a final answer. Alright, so now what does it mean when elasticity E equals 1? Alright, so the term for this is unit elasticity. And what it means, so it's only 1 point, so I gave you credit if you said that much. What I was really looking for, though, was what does it mean? Well, that's when you achieve maximum revenue. Okay, that's revenue, not profit. Right. Elasticity is less than 1, then you have it's inelastic. Right, and greater than 1 is going to be elastic. Okay. And what do these mean? Well, when you're below 1, increase in price will increase revenue. And opposite is true. So for less than 1, an increase in price will increase your revenue. For elasticity greater than 1, increase in price will decrease your revenue. So what that means is, when your elasticity is less than 1, you're going to want to increase price because you want this to go up. But when it's greater than 1, you probably want to decrease your price because that will cause an increase in revenue then. Okay. This guy. So take this integral. Integral of x cubed plus 1 over x dx. This camera straight. Okay. Well, for this first one, we just apply the power rule. That gives us x raised to the power by 1 to x to the 4th divide by your new power. And there's a plus in between, so I do these separately. And integral of 1 over x, well, you can try to make that x to the negative 1 and apply the power rule, but bad things happen because you get a constant. And when you take the derivative to check your answer, you get something that it just disappears and your answer does not check out. So power rule does not apply when you have 1 over x. Okay? In this case, it's just natural log absolute value of x. Now remember the absolute value symbols, that's worth half a point, and don't forget plus c, another half a point. Okay. And for this guy, determine the u to use for u substitution here. So we didn't completely cover u substitution, so I didn't actually ask you to finish. But in this case, the u would be x squared plus 10. Okay. If I were to complete this u substitution, and you get something like this. So to plug this back in, I've got u is x squared plus 10. Derivative of that, move some stuff around. You get 1 over 2x du is dx. So this integral up here is really integral of 3x times u to the 8th. So I substituted to x squared plus 10 for u. And then times 1 over 2x. I can stick that under there because it's just multiplying a fraction. And dx becomes du now. Okay. Well, I've got this 3 in front, I've got this 2 over here, that's 3 halves. I can pull that outside of the integral. And oh look, x over x, that cancels. So I'm left with this guy. Well, I know what the integral of u to the 8th du is. Got the 3 halves still sitting out front. And then we get u to the 9th over 9. But I know what u is, and oh look, a little bit of that's going to cancel actually. So 3 cancels with 9, you're left with 3 down here. U is actually x squared plus 10, 9th, and down here we've got a 6. Alright. So if you check, you take the derivative of this, you'll find it is actually what you originally had. This problem I was only looking for that much, but this would make me happy too. Alright, that is it for quiz 7.